We're going to look at some more problems involving perimeter and area. This first one, we have 3 points that form a triangle, and we want to find the approximate perimeter of the triangle. What you would do is graph the points and connect the points that forms the triangle. I'm not going to do that. I'm going to show you a picture of it so that you can see what it looks like. And it would look something like this. Now, all you need to do is find the 3 lengths. If you look, QS is pretty easy because we can just count the spaces. And we can see that the length is 4 there. So we can say that QS is equal to 4. For the other 2 sides, we have to use the distance formula. So if we look at QR, I'm going to use the x-coordinates of 1 and 4. So I'm going to say the square root of 4 minus 1 squared plus, and then we have 6 and 2, so it would be 6 minus 2 squared. And once we do that, we can see that 4 minus 1 gives me 3 squared, 6 minus 2 gives me 4 squared. That's the same as the square root of 9 plus 16, which is the square root of 25, and that's equal to 5. Now we want to do the same thing for RS. For RS, we have the square root of, and I'm going to do 4 minus 5, so 4 minus 5 squared plus, then we'll do the y's. We have 6 and 2, so it's 6 minus 2. Oops, let's try that again. We have 6 minus 2 squared. That's going to give us a negative 1 squared plus 4 squared. And that's the same as square root of 1 plus 16, which is square root of 17, which ends up being approximately 4.1. Then to find the perimeter, all we do is we add the 3 sides. So we're adding QS, QR, and RS. That would be the same as 4 plus 5 plus 4.1 approximately. So we'll put squiggly lines here for approximately. And then that's approximately equal to 13.1. And since there aren't any units, we can just write units here. So that's our answer. Let's take a look at what they did as well. So again, for the first one, you can either count or use 5 minus 1. For QR, we have this, which gives us our 5. RS, which gives us our square root of 17, or 4.1. Then we find the perimeter by adding the 3, and we get our answer, which is 13.1 units, which was C in our choices. For this next one, I'm just going to kind of guide you through it rather than writing it down because it'll go a lot faster. We have an ice resurfacing machine. I think it's called a Zamboni, and it can resurface 270 square yards of ice in 1 minute. We have an ice rink which has dimensions of 200 feet for the length and 90 feet for the width. And we want to know how long it takes for this machine to resurface the whole skating rink. The first thing that we need to do is figure out the area for the rectangular skating rink. So in order to do that, we're going to do length times width, which gives us 18,000 square feet. Now if I go back real quick, one of the things we need to worry about is that the dimensions are in feet, but the rate at which it can resurface the ice is in square yards. So when we get this answer, it's in square feet, and now we need to convert it to square yards. So what we need to do is come up with a conversion factor. Now we know there are 3 feet in 1 yard, therefore if we're talking about square yards, we also have to square the feet. So it would be 3 squared, or 9 square feet, equals 1 yard. Therefore, we're going to take this 18,000 square feet and multiply it by a fraction, which converts the square feet to square yards. And that would look something like this. Now, the reason why the square feet are on the bottom is so that it cancels with the square feet on the top. If we do that, we're left with square yards. So essentially, we're just dividing the 18,000 by 9, and we get 2,000 square yards. Now, we still have that 270 square yards per minute, and we have this many yards. So what we're going to do is take the rate for in square yards per minute times the time, and that's going to give us the total area here. And since we know the area is now 2,000 square yards, we know the resurfacing rate is 270, and the time we don't know. We set it up like this. We divide both sides by 270, and we get approximately 7.4. So it'll take a little over 7 minutes overall. And that's it for that one. For this next one, it says find the height from point F to segment EG. In this case, if we look at it carefully, we see that a point here, and if we want to find the height has to be perpendicular to the side opposite it. So we have this length right here, and what we can do is we can draw a line that goes from here to here, and that would be our height. So our height can be found if we can see that there's a horizontal or vertical line, in this case a vertical line, and then we can just count it out. 1, 2, 3, 4, 5, and the length ends up being 5. Whoops, or 6. I counted wrong. Let's try again. So it would be 1, 2, 3. Nope, I'm counting correctly. So 1, 2, 3. No, I'm still counting wrong. We'll get this right eventually. 1, 2, 3, 4, 5, 6. I apologize. My eyesight's fading. So we can count, and we get a length of 6. Or what you can do is say this has an x-coordinate of 7. This has these 2 points have an x-coordinate of 1. Therefore, we would say 7 minus 1 gives us our 6. Okay. Using this picture again, we can find the perimeter and the area of the triangle using the same kind of strategy we did before. So we can go through this real quick. We know EG is going to end up being, if we count, 1, 2, 3, 4. So we just count that out. 1, 2, 3, 4. So we get EG is 4. For the other two sides, for EF, we're going to get, let's see, the square root of, we take the x-coordinates for E and F, so that would be 7 minus 1 squared, plus, if we did 7 minus 1, we would do 3 minus 6 squared. That gives us the square root of 6 squared plus a negative 3 squared. So here we have 36 plus 9, which gives us approximately square root of 40, or I'm sorry, exactly square root of 45, which is approximately 6.7. Then we do the same for FG. And for this one, we can say 7 minus 1 squared plus, and this time we'll do 3 minus 2 squared. So that gives us 6 squared plus 1 squared. This is the square root of 36 plus 1, which is approximately 6.1. To find the perimeter, it's EG plus EF plus FG. And I wish there was a quicker way to do this, but this is the only way we can do it. So it would be 4 plus 6.7 plus 6.1, which ends up being approximately, let's see, that's 12, 13, 14, 15, 16.8 units. Okay, and then to find the area, let's go ahead and clear that. Remember again, we found our height by drawing a line from here to here, and we knew that that height was 6. We know that this distance right here ends up being a distance of 4. So to find the area, this time it's half base times height for a triangle. So the base in this case is 4, the height is 6. What I find is easier is just to go ahead and multiply this out. First, 1/2 of 4, those cancel and give me 2. My answer ends up being 12, and remember it's square units this time. So our answer here is 16.8 for the perimeter and 12 for the area. And that's it for this one. Thanks.